Hi, my name is Nicole, and my presentation is on the second law of thermodynamics, specifically on entropy and heat engines. And within this presentation, I will integrate active learning methods and provide materials to implement active learning within a lesson. The main ideas that I will go over in this presentation will be outlining various active learning methods, include instructional components demonstrating active learning methods, provide resources to assist other teachers in finding materials to integrate active learning, while demonstrating active learning techniques for the second law of thermodynamics, entropy, and heat engines. Active learning method is a new approach in the educational system. It goes away from traditional teaching using textbooks and PowerPoints. Active learning promotes critical thinking and successful learning environment. This is because students are more engaged with the lesson and can interact. Some examples of active learning is group discussions, hands-on learning, interactive lectures, and visual aids. While it does depend on the subject matter and the level of difficulty, active learning can be integrated. Active learning method integration can range from simplistic to intermediate to complex. Within this presentation, I implement simplistic active learning and intermediate active learning styles. Simplistic active learning focuses more on visual aids, such as videos and photos. Another technique that can be used, but I didn't use in my presentation, is the 3-2-1 response. Within this technique, students write 3 things learned in the topic, 2 examples, and then 1 area of confusion. An intermediate learning style is more interactive and provides room for critical thinking. For example, students can critically think how in everyday activities where there are spontaneous and non-spontaneous reactions, rather than inside a chemistry lab where for sure there are different types of spontaneous and non-spontaneous reactions. Resources that are provided for active learning that fall under visual aids include online simulations and virtual labs. 3 resources that are very beneficial are from the American Association for Chemistry Teachers. Here there are online simulations of very complex topics that students may not understand when reading through a textbook, but when they visually see it, then they will understand the subject matter. There's also Chem Collective and PHET, where there are interactive online labs that students can look at. If there are not the right materials within the lab, they can also reference the video online. Now that I've gone over active learning techniques, this presentation will include a few that have been mentioned while going over a topic in physical chemistry. So to begin, what is thermodynamics? Thermodynamics is the study of heat into energy, or in other words, the process of heat transformed into work. And work is done when a body is moving against an opposing force, and work is the mode of transfer of energy. And work can either be mechanical or electrical. And within thermodynamics, there is the first law and the second law. I will briefly go over what the first law is, and then the rest of the presentation will go over the concepts in the second law of thermodynamics. While the presentation is focused more on the second law of thermodynamics, an understanding of the first law needs to be understood before we can continue. So the first law of thermodynamics states that energy can be converted from one form to another, but cannot be created or destroyed. So when it says energy can be converted from one form to another, that means energy can be converted between kinetic, internal, and potential. But the main focus of energy in first law of thermodynamics is internal energy. The energy is moving in and out of a system and is equal to the energy of the universe. So if energy cannot be created or destroyed, so why is there a second law that was created? Well, for example, if a book is dropped from 10 feet off the ground onto a table, there is kinetic energy in the book and heat becomes dispersed onto the table. However, if you're thinking about this defies the first law, that heat cannot be created or destroyed. So then why is there thermal energy? That is why the second law has been created. Since the first law says that energy cannot be created or destroyed, but the example of a textbook falling from a certain distance onto a table and then there's thermal heat that has been dispersed, that is where the second law of thermodynamics takes place. So the second law states that matter and energy become dispersed as thermal heat. And by dispersed, it does mean spread out. Entropy is used to measure the amount of dispersal of matter and energy that comes from heat. If entropy is increased, then the reaction is spontaneous. If entropy is decreased, then the reaction is non-spontaneous. And spontaneous and non-spontaneous refer to how far matter and energy has moved rather than the speed of the reaction. And this will be explained more in the following slides. This slide demonstrates an active learning method of spontaneous versus non-spontaneous reactions where students can come up with examples from a chemistry laboratory and from surrounding real-world examples. So the definition of a spontaneous reaction is to occur without work being done. An example of a spontaneous reaction within a laboratory is the reaction of sodium chloride and silver nitrate. With this reaction, when the two substances are mixed together, there is a precipitant reaction that automatically forms without any outside force of heat. I have attached a video at the bottom visually showing students how this reaction is performed, so they can see that the reaction is spontaneous with no heat that was added to it. An example of a spontaneous reaction that's not in a chemistry lab would be a car that is beginning to rust. When a car begins to rust, that is when oxygen and water from the air reduces the ion to create rust. In this example, there is no outside force, it's just naturally occurring materials from the air that is creating this reaction. Now, non-spontaneous does not occur naturally and does need work to be done. So that could be some type of electric current or heat added in order for this reaction to occur. So an example within the laboratory would be obtaining elemental forms of sodium and chlorine gas from a solid sodium chloride block. With this reaction, electrolysis needs to be performed in order to get each element in their form. And an example of a non-spontaneous reaction within the outside world is a TV remote. If a remote does not have batteries, then the remote does not work. However, when batteries are added, there is an electric current that is applied from the batteries in order for the remote to work. So here this slide is showing students that, or they can critically think how spontaneous and non-spontaneous reactions are seen, not just only in a chemistry lab, but they're seen everywhere. And then the video provided is another active learning method where students can see how reactions occur spontaneously. Here's a visual of entropy, and this visual, it shows how matter is dispersed. On the left is a non-spontaneous reaction where all the matter is dispersed in the corner, all clustered together, while a spontaneous reaction is the dispersal of matter and energy, and it is everywhere. So the value of entropy is positive, the reaction is spontaneous, which indicates further dispersal of matter and energy. However, if the value of entropy is negative, the reaction is non-spontaneous, and there is more order within the system. So an example of entropy that students can visualize is a child's playroom. So if a child's playroom has their toys scattered all over the floor, that is an example of a spontaneous reaction because toys are dispersed all over the floor in a random disorder. However, if a child's toys are placed neatly in their bins, that is an example of a non-spontaneous reaction because there is order within that system. This slide shows the summary of entropy, where it summarizes that a spontaneous reaction occurs naturally, has a positive entropy value, and that the matter within the system is randomized. While in a non-spontaneous reaction, it does not occur naturally, it needs work, so any kind of electrical current. The entropy value is negative, and the disorder is within one area. Heat engines are an example of the second law of thermodynamics. So when energy is formed, not all of it is transformed into heat and is useful. So heat engines consist of steam engines and gasoline, which produces heat for movement. So that fuel is burned into mechanical work by an opposing force. So most of the heat does provide movement for the engine, but most of it does leave the engine. Therefore, most engines work only between 10 to 20% efficiency. Engines can only work if heat is moved from a high temperature area to a low temperature area within the engine. Efficiency is used to describe by the temperature of the heat supplied to the engine and is removed. So on the left there's a diagram, a simplistic diagram of a heat engine, where at the top it shows the high temperature source where the fuel supply is. Once the engine is turned on, then that fuel is converted into heat into the engine. Whatever is used to provide work and to actually move the engine provides work, while the remainder goes to the low temperature body and is released into the environment. As you can see, modern train locomotives have an efficiency of 20 to 25%. So all of the gasoline that is used to power these trains, they're only working at a 20 to 25% efficiency. That's all of the energy that is used, that is actually used and created by work, while the remaining 75% is just released into the environment. And at the bottom, I have linked a simulation of heat engines going over each mechanism on how they work and going into more detail on that. Within this presentation, a few active learning methods have been implemented, such as visual aids in pictures and videos, while also implementing a more intermediate active learning method where students are able to critically think of various types of spontaneous and non-spontaneous reactions within the second law of thermodynamics.